everyone, welcome to the Solving Equations with Variables on Both Sides guided notes. Let's get started here. A solution to an equation is the value of the variable that makes a balanced equation. Is x equal 3 a solution to the equation 2x plus 5 equals 11? If I substitute 3 in for x, is my equation balanced? Or does 2 times 3, which equals 6, plus 5, does that equal 11? Yes. How do I know? I substituted 3 for x, which means 2 times 3 plus 5 does equal 11. Is x equal 3 a solution to the equation 10 plus 6 equals 15? If I substitute in 3 for x, does that make the equation balanced? Does 10 plus 3 equal 15? No. How do you know? I substituted 3 for x, and 10 plus 3 does not equal 15. Equations can also have variables on both sides. However, the definition of a solution does not change. The value on both sides will still be the same. Let's look at the equation 2x plus 7 equals 3x plus 3. Is x equal 3 a solution to the equation? So if I substitute in 3 for x, is the equation still balanced? So 2 times 3 is 6 plus 7, and then I have 3 times 3 is 9 plus 3. So 6 plus 7 is 13, and does that equal 12? No. Is x equal 3 a solution to the equation? No. How do you know? Well, using substitution. Is x equal 4 a solution? Well, let's substitute in 4 and see what happens. Using the same equation, let's substitute in 4. So 2 times 4 plus 7, does that equal 3 times 4 plus 3? Well, 2 times 4 is 8 plus 7 gives me 15. And 3 times 4 is 12 plus 3 is 15. So 15 equals 15. So x equals 4 is a solution. How do you know? Same thing, using substitution. Are there any other numbers besides 4 that could be a solution to the equation? The answer to that is no. No other number will give the same value on both sides. 2x plus 1 equals 2x. Is there a value that you could substitute for x that would make both sides equal? So I put a number for x, multiply it by 2 and add 1, and then make it equal 2 times that value. Is that going to work? The answer to that is no. How do I know? This right here, this left side, will always be 1 more than the right side. If you have an equation with variables on both sides, it is possible that a solution does not exist. So like for this equation, there's no number that I can put in there that's going to give an equal on both sides, because this side here on the left will always be 1 more. Now let's look at the equation 2x equals x plus x. Is there a value that you could substitute for x that would make both sides equal? Yes. How do you know? They are the same expression. 2x is the same as x plus x. So any value that I put in for x will give me the same value on both sides. How many different values could you substitute for x that would be a solution? And no matter what value I put in for x, it's going to be true because they are the same expression on each side. So I can place an infinite amount of different values for x in the equation. If an equation has variables on both sides, it is also possible that there are infinite solutions. In summary, equations with variables on both sides can have one solution, no solutions, or infinite solutions. Can an equation have exactly 2 solutions? Explain why or why not. No, only one value or infinite values will make an equation balanced. Explain how you can check to see if you correctly solved an equation. Substitute your solution into the equation, simplify, and both sides of the equal sign should be the same. These are some problems from Meg's homework. Check her solution by substitution. Show how you checked her work. So here's the equation here. 5x minus 2 equals 3x plus 6. Meg got a solution of x equals 4. Let's substitute that in and see if it works. So 5 times Meg's solution of 4 minus 2, does that equal 3 times 4 plus 6? So 5 times 4 is 20 minus 2, and then 12 plus 6. 20 minus 2 is 18, and 12 plus 6 is 18. Since 18 equals 18, yes, she solved it correctly. Negative y plus 8 equals 4y plus 14. So we have a negative y, and her y is a negative 2. So I'm going to use parentheses there. Negative y plus 8. Does that equal 4 times her y, negative 2, plus 14? So a negative 2 is 2 plus 8. 4 times a negative 2 is negative 8 plus 14. 2 plus 8 is 10, and negative 8 plus 14 is 6. 10 does not equal 6. I know that she solved the problem incorrectly. 3m plus 2 equals 5m minus m plus 6. Let's substitute her solution of m equals 4 into the equation. So 3 times 4 plus 2, does that equal 5 times 4 minus 4 plus 6? 3 times 4 is 12 plus 2 equals 20 minus 4 plus 6. 12 plus 2 is 14. 20 minus 4 is 16 plus 6 gives me 22. 14 does not equal 22. That means she solved it incorrectly. Let's do a quick review of how to solve equations. So when we are solving equations, we want to get the variable isolated. That means just by itself, and we just want one x, or one whatever the variable is. So 2x plus 7 equals 3. We're going to get rid of the 7 by minusing 7 from each side to keep it balanced. And that gives me 2x. 7 minus 7 will cancel. 3 minus 7 equals a negative 4. So I know 2 x's equal a negative 4. I'm going to divide each side by 2 to get 1x. And that gives me negative 2. So x equals a negative 2. Because negative 4 divided by 2 is a negative 2. I'm going to check my work by substituting in my value. So 2 times a negative 2 plus 7, does that equal 3? Well, 2 times a negative 2 is a negative 4 plus 7 equal 3. Yes, it does. So I did it correctly. 3y minus 5y equals 10. Before I isolate my variable, I'm going to combine like terms. 3y minus 5y is a negative 2y equals 10. Now to get 1y, I'm going to divide each side by negative 2. And 10 divided by a negative 2 is a negative 5. So y equals a negative 5. Let's check my work. 3 times a negative 5 minus 5 times a negative 5. Does that equal 10? Well, 3 times a negative 5 is a negative 15 minus 5 times a negative 5 is a negative 25. Make sure you're doing your parentheses here so you don't get confused about the minus and the negatives. Does that equal 10? So negative 15 minus a negative 25 is going to be plus 25. Is negative 15 plus 25 10? Yes. So I did it correctly. Next question. 2 times the quantity x minus 3 minus 1 equals 1. Let's simplify first using the distributive property. So 2 times x is 2x. 2 times a negative 3 is a negative 6. Minus 1 equals 1. Now I'm going to combine like terms. 2x minus 6 minus 1 is minus 7 equals 1. I will add 7 to both sides to get my variables by themselves. And I get 2x equals 8. Divide each side by 2 to get 1x. 8 divided by 2 equals 4. So x equals 4. Let's substitute that in to see if that's correct. 2 times 4 minus 3 minus 1. Does that equal 1? Let's simplify. So 2 times 4 minus 3 is 1 minus 1. Does that equal 1? 2 times 1 is 2, minus 1 equal 1. Yes, that is correct, so I did it correctly. Solving equations with variables on both sides is very similar to solving equations with variables on one side. To solve for the variables, collect all variables on one side and all constants on the other. Remember, the equation needs to stay balanced. Therefore, whatever action you do to the one side of the equal sign needs to be done to the other side of the equal sign, and that will help keep it balanced. Let's take the equation 4x minus 1 equals 3x plus 5. When solving equations with variables on both sides, it doesn't matter on which side you collect the variables and on which side you collect the constants. It's best to make the decision based on the equation. So basically, I can collect my variables on the left or the right. It's going to make the answer the same. Looking at the equation, 4x minus 1 equals 3x plus 5, I can either subtract 3x from both sides to collect the variables on the left. That will move all the variables over here to the left. Or I could, let's erase this, or I could subtract 4x from both sides. And if I do that, all the variables will be here on the right. If I subtract 3x, I will have x on the left. If I subtract 4x, I will have negative x on the right. I can do either one, but I am going to choose to subtract 3x so that I have a positive x, as that will be easier to work with. Show your work on the equation below. So I'm going to minus 3x from each side. This will cancel, and now my equation reads 4x minus 3x, so that's going to give me x minus 1 equals 5. After subtracting 3x from both sides, you should be familiar with how to finish solving for the variable. Finish solving for x on the equation below. So this is an equation that I've seen before, or a type of equation that I've seen before. So I'm going to add 1 to both sides to get the x by itself, and this right here will cancel. So now my equation says x equals 6. Now let's analyze this equation right here. Negative 2x minus 5 equals 5x minus 19. Let's first collect the variables to one side. If I want to move the 2x's over there, then I would add 2x to both sides, which I could do. Or if I want to get the 5x over here, I would have to subtract 5x from both sides to put the variables on the left. Again, either one is correct. One might be a little bit easier as far as working with negatives. I'm going to choose to add 2x to both sides, so that gives me positive x's. If you want to do something different, if you want to subtract the 5x, that's okay as well. Show your work on the equation below and then completely solve it. So I chose to add 2x to both sides. Negative 2x plus 2x will cancel. So I have negative 5 equals 5x plus 2x is 7x minus 19. Now I'm going to add 19 to both sides. That gives me negative 5 plus 19 is 14 equals 7x. Last step is to divide by 7. That gives me 1x. Divided by 7. 14 divided by 7 is 2. So I get x equals 2. And I could substitute that in and simplify and check to see if my work is correct. Sometimes simplifying the expressions on either side of the equal sign will be important. For example, with this equation, 4 times x minus 3 equals x plus 4. Simplify both sides of the equal sign. So to do the left side, I need to use the distributive property. 4 times x is 4x. 4 times a negative 3 is a negative 12. And then x plus x is 2x. Plus 4. Now think about which side you want to collect your variables on and why. So I can either subtract 2x from both sides, like that, or I can subtract 4x from both sides. Now I'm going to subtract 2x from both sides, same reason, because it will keep my x's positive. Okay, in the space provided below, show your work to solve the equation. I've already simplified it here above, so I'm just going to rewrite that here. So 4x minus 12 equals 2x plus 4, and I decided to subtract 2x from both sides If you do it the other way, that will work as well. This will cancel, and I get 4x minus 2x is 2x minus 12 equals 4. I'm going to add 12 to both sides to get the variables isolated. This will cancel, and writing over here, I get 2x equals 4 plus 12, which is 16. Divide by 2, divide by 2. I get x equals 16 divided by 2, which is 8. Practice. Okay, let's practice solving these equations. I'm going to simplify first. I've got to distribute this negative here. Right here, this negative, I got to distribute to the m and to the 5. So now my equation says negative m minus 5 equals a negative 2m plus 1. Looking at this, I can add 2m to both sides or add m. I'm going to go ahead and add 2m. Again, if you do it differently, you will get the same answer. So adding 2m to both sides, negative m plus 2m gives me m minus 5. That cancels, equals 1. Adding 5 to both sides, that gives me m equals 6. Let's check my work. So a negative, and then inside I have my m. 6 plus 5. Does that equal negative 2 times 6 plus 1? So a negative 6 plus 5 is 11. So negative 11. Negative 12 plus 1 is also a negative 11. So yes, that checks out. 3y minus 8y equals negative 4y plus 3. Let's simplify this first. So that's a negative 5y, because 3y minus 8y is negative 5y, equals a negative 4y plus 3. I'm going to add 5y to both sides. Same reason, to keep my variables positive. That cancels, so I have 0 equals negative 4y plus 5y is y plus 3. Subtract 3 from both sides. I get y equals a negative 3. Let's check my work. 3 times a negative 3 minus 8 times a negative 3. Does that equal negative 4 times a negative 3 plus 3? Simplifying, so that's negative 9. Negative 8 times a negative 3 is plus 24. Does that equal 12 plus 3? So 12 plus 3 is 15, and negative 9 plus 24 is also 15, so it checks out. Okay, so let's simplify. I have 2x minus 6 minus 1 equals 5x minus 4. That simplifies to 2x minus 7 equals 5x minus 4. Subtract 2x from both sides. I get negative 7 equals 3x minus 4. Add 4 to both sides. I get negative 3 equals 3x. Divide each side by 3, and I get x equals a negative 1. Substituting that in to my equation to check my work. So I have 2 times negative 1 minus 3 minus 1 equals 5 times a negative 1 minus 4. So 2 times a negative 4 minus 1, and then 5 times a negative 1 minus 4. This is going to simplify to negative 9, and negative 5 minus 4 is also negative 9, so that checks out. Remember that equations with variables on both sides can also have no solutions, like the equation 2x plus 1 equals 2x. Let's try solving this equation by collecting the variables on one side and the constants on the other side. So let's look at our equation right here. Let's try and get the variables over onto the right side. So we're going to subtract 2x from both sides. So minus 2x minus 2x. Those cancel, and now it says 1 equals 0. After subtracting 2x from both sides, your equation now says 1 equals 0. We know that 1 does not equal 0. This is a false statement. Therefore, this equation has no solution. So if you work to solve it and you get a false statement, then the equation will have no solution. Let's look at the equation 3x minus 4 equals 2x plus 1. Simplify the right side of the equation. We have, so if we're going to simplify this part right here, we have 3x plus 1. To collect the variables on both sides, we will, let's say I want to get the variables here onto the left. So let's subtract 3x from both sides. Once I do that, this cancels and that cancels. So now my equation says negative 4 equals 1. So after subtracting 3x from both sides, your equation now says negative 4 equals 1. This is a false statement. Therefore, this equation has no solution. Explain in words how you know if an equation has no solution. If all the variables cancel out and the remaining equation is false, then there is no solution to the equation. Practice. Prove that these equations have no solution. So let's go ahead and try and solve them. Looking at this first one right here, let's add 8x to both sides. And now my equation reads 5 equals negative 2, which means the equation has no solution because 5 does not equal negative 2. Let's do this one right here. Let's first simplify it. So I still have 4x plus 3, and then 2x plus 2x is 4x. Then I'm going to have a minus 1. Let's subtract 4x from both sides. And they both cancel, and now my equation says 3 equals negative 1, which means the equation has no solution. This equation right here, let's simplify the left side by distributing. So I have negative 3x minus 6 equals negative 3x plus 6. We're going to add 3x to both sides. Cancel, cancel. Now my equation says negative 6 equals 6, which is not true. So my equation has no solution. This equation right here, let's simplify the right side. It says 5x minus 1 equals 5x plus 9. Going to subtract 5x from both sides. Cancel, cancel. Now it says negative 1 equals 9, which is not true, so my equation has no solution. Recall, equations with variables on both sides can have one solution, no solution, or infinite solutions, such as the equation 2x equals x plus x. Explain why the equation 2x equals x plus x has infinite solutions. Well, if I simplify this right here, that equals 2x. So it says 2x equals 2x. And that's the same expression on both sides. Therefore, it will have infinite solutions. Let's try solving the equation 2x equals x plus x to see what an equation with infinite solutions looks like when solved. First, let's simplify the expression on the right. So it says 2x equals, so x plus x, so 2x equals 2x. To collect the variables on one side, we're going to subtract 2x from both sides. Show your work on the equation below. All right, so now my equation says 2x equals 2x. If I were to happen to subtract 2x from both sides, now my equation will say 0 equals 0. After subtracting 2x from both sides, the equation now says 0 equals 0. This is a true statement. Therefore, the equation 2x equals x plus x has infinite solutions. So this time, if I cancel out all my variables and I get a true statement, my solutions are going to be infinite. Now we will analyze the equation 3 times the quantity x plus 1 equals 3x plus 3. Solve this equation by simplifying and collecting the variables on one side. Show your work on the equation below. So let's simplify the left side by using the distributive property. So 3 times x plus 3 times 1 is 3. So my equation says 3x plus 3. You should notice that the expressions are equal, as though the solutions will be infinite. But if you don't notice, we can still solve it, and it's going to give me a true statement. So if I minus 3x from both sides, my equation says 3 equals 3. So it says after simplifying and subtracting 3x from both sides, the equation now reads 3 equals 3. This is a true statement. Therefore, this equation has infinite solutions. Explain in words how you know if an equation has infinite solutions. If my variables cancel out and I'm left with a true statement, my equation has infinite solutions. Prove that these equations have infinite solutions. So let's go ahead and simplify the right side of the equation. We have 3x plus 3x, which is 6x, plus 1. Now I can see that they are the same expression, but if I go ahead and try and solve it, I subtract 6x from both sides, and then I get 1 equals 1, which is true, so this has infinite solutions. Next question right here, let's distribute that negative. So I have a negative x, and then negative times a negative 5 is going to give me plus 5, and that equals negative x plus 5. If I add x to both sides, I get 5 equals 5, which is true, so this has infinite solutions. Negative 5y minus 2y equals a negative 7y. Combining those terms are on the left, I have a negative 7y, which equals a negative 7y. If I add 7y to both sides, I am left with 0 equals 0, which means this equation has infinite solutions. This question right here, let's distribute to simplify. 2y and then plus 2 times 5 is 10 equals 2y plus 7 plus 3, which is plus 10, minus 2y from both sides, and I get 10 equals 10, which is true. Therefore, this equation has infinite solutions. Do you think you could create your own equation with variables on both sides that have one solution, no solution, and infinite solutions? Let's first notice some patterns with these equations. So here we have two equations, and they both have one solution. Here we have two equations, and they have no solutions. And here we have two equations, and they have infinite solutions. So it asked me to fill out this table, and the first question says number of variables on both sides. So we have, on this equation right here, we have 2, and then we have 3. This equation right here, I'm going to simplify first. So 3y minus 8y is a negative 5y. So I have negative 5 on one side and 1 on the other side. Let's look at this equation. So I have 2 variables on this side and 2 variables on the right side. This equation right here, let's simplify the right side before I answer. So I have 3 variables on this side and 3 variables on that side. This equation right here, so I'm going to simplify. I have negative 7y. So I have negative 7 and negative 7 variables on each side. Simplifying the left side of this bottom equation, so I have 2y plus 10 and then 2y plus 10 on each side. So I have 2 variables on each side. Now it's asking for the number of constants on both sides. So here I have 7 and 7. On this one I have 0 and 12. This question right here I have 1 and 0. This question right here I have negative 4 and 1. This question right here I have 0 and 0. And then the bottom one I have 10 and 10. What do you notice about the number of variables and constants with equations that have one solution? So these equations right here at the top, with the number of variables, they are different, and that will be true with equations with one solution. They will always have a different number of variables on each side. With the constants, they can be the same or they can be different. Now I ask, what do you notice about the number of variables and constants with equations that have no solution? So if we look up here, the equations with no solution are the ones right here in the middle. And if you notice, the number of variables will be the same. The number of constants will be different. And this is true for all equations with no solution. Now it asks, what do you notice about the number of variables and constants with equations that have infinite solutions? So down here at the bottom, the equations that have infinite solutions have the same number of variables and the same constants on each side. And that is essentially because the expressions are the same on each side when they are simplified. Practice. Analyze the equations below. Complete the table using what you know about the number of constants and variables. First, let's simplify the equations and then we can compare variables and constants. So we have 6x minus 3. Using the distributive property, we have 6x, and then 3 times a negative 1 is negative 3. And I actually noticed that they are the same on each side, so they have an infinite number of solutions. Number of variables on each side is 6. Number of constants on each side is negative 3. Let's look at this next equation. I noticed that my variables are different. That's a first sign that I'm going to have one solution. Number of variables on each side is 8 and 5. Number of constants on each side is 3 and 6. This next one, we're going to simplify it. So negative x plus 5x. That's 4x plus 1 equals 4x minus 3. I notice that I have the variables on each side are 4 and 4, and my constants are 1 and negative 3. So same variables, but the different constants. That's going to give me no solution. Lastly, it says create your own equations with variables on both sides that have one solution, no solution, and infinite solutions. Obviously, there's a bunch of different answers you can do. You can compare yours with mine. So let's first do one solution, meaning I'm going to need a different number of variables on each side. And it doesn't really matter about my constants. So I'll say 2x plus 1 equals 3x plus 4. Number of variables on each side are 2 and 3, and then constants are 1 and 4. Now let's do an infinite number of solutions. So basically the equations are going to need to be the same. So let's do 3x plus 2 equals, I could just write 3x plus 2, but let's make it a little bit different. So I have 2x plus x plus 2. Number of variables on each side is going to be 3 and 3. Number of constants is going to be 2 and 2. Last one, let's do a number of solutions would be none. So basically my variables are going to need to be the same and my constants are going to need to be different. I'll just leave it like that. 2x plus 2 equals 2x, I guess it would be plus 0. Number of variables on each side are 2 and 2, and constants would be 2 and 0. Okay, everybody, that's it for today. Thank you.